Hello and welcome to advanceded.weebly.com. I'm just going to take you through an exercise today in this video tutorial in relation to the ellipse and parabola. So I'm just going to get straight into it here. I'm going to start on this exercise here you see on the top right hand corner. Okay, you can see it's the logo of an Atlantic Homecare Trademark. A portion of an ellipse and a parabola have been linked together in the formation of the letter A. So you see it there as we're going to draw it in a few minutes. Okay, the information we're given, which is critical, is the curve ABC is based on an ellipse, and this curve ABC is based on an ellipse with its minor axis 80 millimeters, and the curve AC, this curve here, A over to C, is based on a parabola with its vertex at A. So the important bit in relation to that parabolic curve is that its vertex is here at point A. And you're basically asking again to reproduce the drawing of the trademark. Okay, so just a few things to look at here to get started. The curve ABC. Okay, we're told that's based on an ellipse with a minor axis of 80 millimeters. Okay, so we can see from the drawing here that the minor axis is going to be coming down this way. Alright, the fact that it is 80 millimeters here, and I can see from this mid-axis here, which is part of our major axis, we can see up from there to point C is 40 millimeters. Now the fact that that's 40 millimeters, we know that's going to be the highest point of it because the minor axis itself is 80 millimeters in length. So that means 40 millimeters above and below the major axis, which comes across here, is going to be both the highest and the lowest point on the ellipse. So that again in turn tells us that this line here is the actual position of the minor axis. Okay, so I'll just write that in there just to clarify that. That's our minor axis coming down this way, and we know this guy coming across here is part of our major, so half our major axis there. So we need to ask ourselves, what else in relation to the ellipse do we have? Alright, we have our minor axis here, we know the length of that, and we have half of our major axis now we're after discovering from here, from the minor axis over as far as B. We also have a point A, which we can locate with the given dimensions that we know is on the curve ABC, which is also on the curve of the ellipse, excuse me. Alright, I'm just going to get started. First of all, I'm going to take the more simplistic bits here first, the side and the angles of the letter A itself. I'm going to take into consideration the heights that's given, the widths that's given, and I'm going to start plotting everything I can basically with the information there that's given on the initial question. Alright, I'm going to look at it first of all, overall height of 170. I'm just going to come down enough on the page. I'm going to mark in my baseline. Okay, I'm going to call that my XY. So it's important, guys, to start off also with the correct pencil. Okay, make sure you have a H or 2H pencil for your drawing purposes. I'm going to mark out these dimensions across here, 165, so you see 60, 70 and 35. I'm going to mark those off also to get started with. Okay, so 60, 70 and 35. We're given here on the top an overall height of 170. I'm just going to mark that in as well. Here up to 170. I'm just going to put in a height line there, or my altitude of that letter A. And nice and light just to start with. Now, next thing we can see here in the given information, from the points here on the 35 millimeter mark, okay, we're coming up at an angle of 65 degrees until it hits our top height here of 170. Okay, so I'm just going to draw that in lightly first. Remember, this is 65 degrees now, it's not 60 degrees set square. So you need to get your protractor, measure there from 0 up to 65. And we can, while we're doing that, measure here as well on the second point. And 65. I'm going to draw those two in place. from your base point up through that angle, and likewise here. Okay, now we have this measurement here on top of 15 millimeters where that line is after hitting the top line. I'm going to measure out that 15 millimeters. So I'll just throw that in slightly heavier just to indicate the width of it there. Okay, so the next thing we need to find out, we're not necessarily told the angle of the left hand side here, or this leg of letter A. Okay, we have our widths, we know our height up here is 10, we know there's a curve here of a radius, an arc of a radius of 30 millimeters. Okay, and this guy over here, a radius of 15 millimeters. So we're going to measure up 10 first of all for these steps, and on this side up 30, and here directly above it up 15. So we're marking those and the center points first. Okay, so now that I have those marked, I'm just going to bring my point here, my center point, across horizontally, because we know that's where the arc stops. So I'll bring that across horizontally. Light construction line, remember, and I'm going to swing that arc there just to have that part done at a radius, remember, of 15 millimeters. And that brings me up as far as our point A. Okay, on the other side here we have a radius of 30 millimeters, but we're not yet sure where that actually stops in order to meet this side of this inclined line. Right, so I'm going to draw in my arc first of all of radius 30 millimeters, which I've already set out. Light line for now because we don't yet know where it finishes. Okay, so what we're dealing with here now is we need to go back to our previous knowledge. Okay, and what we're dealing with is the center point essentially of a circle. Okay, center point of a circle, and we're dealing with a line here that is, as we can see from the drawing, the construction is tangential to it. Okay, not given the angle of that line, so we need to problem solve that and determine what angle it's coming at. So that means looking at the information we're given and seeing what we can do with that. Alright, so what I'm going to do, I have my center point here. I can clearly identify one point on the end of the line, which is up here on my drawing. Okay, so essentially what we have is our circle, and we have a point on the line that's running tangential. So we think back to when previously we got our tangent line to a circle from a point P, which I'll name here, which is outside the circle. Okay, so here's your point P, here's my circle, and now I'm going to construct the tangent to it. And if you remember back, the way we do that is we join our center point of the circle in question to point P, light construction line. We bisect that line in order to get the center point. Okay, so those two arcs cross, just going to join those up in order to get my center point. And to find a point of contact between the line, the tangent line, and the curve, you swing an arc from that bisecting point, set your radius to P, and swing that arc like so. Okay, where that arc crosses our existing arc down here, that gives us our point of contact exactly there, and we join that back to P. Okay, And while I have my set square set up, we can see here that this line from the symbols given on the internal side of that leg is parallel to it from this point here. So I'm just going to draw that in as far down as we need to, lightly for now, because you can see the break in it here of 5 millimeters. So I'm going to come up here, I'm going to set my sliding set square up here just to measure that 5 millimeters perpendicular to that line. Measure that here, slide it back to it, and I'm going to draw in that line like so. And that there represents the break in the leg as it's given in the question. Right, so now I can finish off the leg as I'm calling it on the right hand side. Actually I'm going to leave this light yet because you can see here where the little arcs cut through it and it won't be visible, only as a construction line there. So that's that part. We got our point which is tangential to the curve. Tangential to that here, we have point A in place, and now I'm going to start setting out my heights here in order to get my minor and major axis. You can see the minor axis is directly above the butt of the leg here. I'll draw that line up. And I'm going to measure up 25, 25 and 40 to get point C. 25 is 50 and 40 will give you point C. This here represents my major axis. Okay, sorry, we're actually not sure of the length of that yet, so we just have the position of it, but we do know the length of the minor axis. This here is point C. Over here, we're told it's 80 millimeters long, so I'm just going to measure down 80 millimeters, and I'm going to mark where the other end of that would be. I'm going to call that C1. That's just the other end of, or the other vertex of the minor axis. So now what we've identified in relation to the ellipse is we have our point A, which is a point on the curve. Point B we don't yet have, we know it's somewhere on this line, and we have point C. Okay, and of course this here, I'll just put my colour pens, always handy to have at close by as well. Just going to mark in the minor axis there in orange. Alright, we have the length of that. So once we have the length of that, first things first, we know we can draw our minor circle. Okay, so I'm just going to draw, because we're only drawing on one side of the minor axis, I'm just going to draw that as a semicircle rather than the full circle. Okay, the next thing we need to determine, okay, is the length or the radius of the major circle. Okay, and the way we do this, if you have a point on a curve which is outside, okay, point on a curve which is outside, point on our curve, excuse me, and we have our minor axis. Okay, we're reversing roles from our auxiliary circles method. So when we have our auxiliary circles, we know we divide our circles into 12 equal parts, and where the dividing line cuts the major and minor circle, we draw our lines parallel to either the major or the minor axis. So in this case, I'm going to get my point A, and I'm going to draw a line parallel to my major axis until it hits our minor circle. Okay, that now hits our minor circle here. I'm going to draw a dividing line from my center point out through that intersecting point. So I'm going to extend that on another bit. Okay, so I've extended that in until it hits our circle first of all. That gives us a point on our minor circle in which the dividing line must come through from our center point O, we'll call it. From that line, extend it out through the point, go back to our point A, which is on the curve of the ellipse, and I'm going to drop that straight down in this case, okay, until it hits that line at the given point X, I call that. Okay, so you're basically reversing the auxiliary circles method with the given point in order to get the radius of both our major and minor circle. Now we have the major circle, so now we have the radius from O to X of the major circle. So I'm just going to draw a portion of that in place that's required to complete the question. From O to X, I'm going to swing that arc there. Right, where that arc is a portion of our major circle crosses our major axis, that now gives us point B. Alright, so that's your point B up here. So now that we know that, we now also have our major axis, okay, or in this case we're just using half of it, which is one side of the ellipse. Alright, so after that we have our two circles here. It's down to dividing them up into the 12 equal parts in general. Because we're dealing with half of it, we're divided into 6 equal parts, and we plot our points now as normal to get our shape of the ellipse. And for this guy here on the lower side, I'm just going to mirror that through the major axis. To measure my distance above it, which is 20 millimeters, I'm going to put that down, project it down below. Just to give me this point here. Now I can join it back to A. So now I have my ellipse point A, B, C drawn in. We just need it as far as point A. We don't need to mirror it right down here. So just to go back over that, we got our minor circle and our major circle here. Divided those into 1, 2, 3, 4 equal parts. You can say for this would do it. And where each dividing line, for example, and just recap on that, where each dividing line, I'll pick one here. Where it crosses the major circle, we draw a line parallel to the minor axis. Okay, you can see the little arrows here to indicate that. Where the same line crosses the minor circle, draw a line parallel, in this case, to the major axis, and that plots your point where those two lines intersect on the curve. Alright, you do that with all these other dividing lines, and you plot your few points like you see here on the drawing. Okay, so that's your ellipse A, B and C complete. Now that we have that bit done, just before we move on, I can now finish off that side of the letter A down as far as the ellipse. And also on this side, I can bring it down as far as the top of the ellipse. Okay, I'm not yet bringing it down through the bottom because we just have to draw the parabola or the parabolic curve before I can finish that off. Okay, one more little arc down here I can finish. Guys, for anyone that has this supreme compass that I have here, just a little tip for that. Sometimes, depending on the compass you have, the arms have a little elbow here where they bend. So no harm, put a bit of masking tape around them. That prevents them from kicking in here when they're loose and you're trying to draw an arc. It just makes them more stable and less hassle or trouble when you're drawing your circle. Alright, so and that portion finished. Now it's down to drawing the curve AC. Alright, so getting back to the question, we're told that the curve AC is a parabola with its vertex at A. So if we know here our vertex is at point A, okay, I'm going to draw a line vertical from that, okay, in order to create my rectangle. I'll actually do that in a different colour here. I'll use colour pink. Like I said earlier, no harm to have a few colours at hand. I'm going to draw that from the vertex up here. Okay, and we know that point C is on the curve as well. So I'm just going to draw a line across from point C until it meets that. Alright, so this here now is going to give us our rectangle for the parabolic curve. Okay, so one rectangle there. The reason I put that in colour, as you can see, there's a lot of construction there. So a few little different colour pins kind of take you through the different steps in each question. Now we have point A, which is our vertex, point C on the curve. I'm going to go through the method now of dividing up our side here. I'll call this A1. I'll call this A2. Right, so we have A, A1, A2 and C. That's the rectangle we're looking at. So what I'm going to do now, I'm going to divide up A2 to C. And it's important you show this method of you dividing your lines. Okay, draw a line off at an angle. Just get your compass. Don't have to actually measure and I'm going to divide the line into 4 equal parts. So I'm going to go 1, 2. Sorry folks, apologies there, while I was dividing the lines my battery decided to go dead. So just getting back to that, I was dividing the lines there 1, 2, 3 and 4. Remember, we're dividing this line CA2, which is part of the rectangle for the parabola, into equal parts. So we brought number 4 back to the end, and 3, 2 and 1 must come back parallel to it until they hit the line we're actually dividing. I did the same thing over here on the line A1 to C, which is the side of a rectangle, or the top in this case if you want, depending how you look at it. And the same method basically here, divided 1, 2, 3, 4, brought the relevant points back to the end of the line we're dividing, and the other guys 3, 2 and 1 back parallel. Alright, what you missed out on there was basically your central axis here of the parabola is this line A2. Okay, that's your axis of the parabola, because we know point A is the vertex. So any of the points on the side of the rectangle opposite the axis, they all come back to our vertex, which is point A. The other guys along here, they simply come up number 3, 2, 1 parallel to our axis, and where the the corresponding points along here are those lines joined to the vertex. That helps us and gives us our points that are on the curve. Okay, and then I basically join the points back as far as point C from A to give us our parabolic curve. So after we get that done, one last thing I can do here, I can finish out my solid lines here in order to complete the question. There you go. If you want to shade in that after, you can, but just be careful that you don't cover over your construction lines, because remember guys, you must reproduce your drawings showing all construction lines if you're to get your full marks. Alright, so just to take your time, go through my video. Hopefully those of you that's watching through YouTube can give me a thumbs up if you find the video helpful. Thanks very much.